Our next topic is transpose of a matrix. To understand this definition, see, I take a matrix. Suppose I take a matrix 2, 3, -1, 4, 6, 2. This is matrix A. Now, I create a new matrix from this given matrix. Suppose I do a new matrix by this way. First row I convert into first column. First row is now first column. Second row is second column. If there is third row, I convert into third column. So all the rows are converted into corresponding columns. So this new matrix is said to be transpose of matrix A, and it is denoted as A transpose, capital T over A, or its another symbol is A dash. This is denoted as A transpose or A dash, transpose of matrix A. Say this matrix is 2 by 3, its order is 2 by 3, and it is converted into 3 by 2. 2 by 3 is converted into 3 by 2. So if any matrix is m by n, order of given matrix is m by n, then it will be converted into a new matrix of order n by m. So its definition can be written as, if all the rows of given matrix are converted into corresponding columns, then new matrix obtained thus, new matrix obtained thus is said to be the transpose of matrix A. It is denoted as A transpose, or keep a dash over it. And here this is example. So if this is A, then this is its transpose. So here you can see that order of A is 2 by 3, and look here, order of A transpose is 3 by 2. So if A is matrix Aij, its order is m by n, then A transpose, it will be a matrix whose order will be n by n. Now see, A11, here it is A11, same. 2 is at the same place. Now see, this is A12, 3 is A12, and now here is A21, minus 1, first row, third column. So A13, and look here, it is at third row, first column. So A31. So A13 is A31. A21 is A12. A22 is A22. A23. A23. This element is in second row, third column. And here it is in third row, second column. So A23 is here A32. So in matrix A, Aij, any element Aij, it will be then in its transpose, it will be Agi. So this is meaning of transpose of any matrix. Now symmetric matrix. Symmetric matrix. To understand this definition, say I take a matrix A. This is a square matrix. I am taking a square matrix. Matrix A is 2, 3, 1, 4, 6, 5, 0, minus 1, minus 2. This is a square matrix. Sorry, I have to change the example. I take matrix 2, 3, 5, 3, 4. Here I take 5, 7, 9. This is a square matrix. Now say, I take its transpose. Its transpose is, see, first row, now I convert into first column. First row, convert into first column. Second row is now second column. Third row, third column. Converting all three rows into corresponding column. First row is first column, second row is second column, third row is third column. Matrix obtained thus is transpose of given matrix. So it is A transpose. Now look, observe both matrices. See, they are same. 2, 3, 5, 2, 3, 5, 3, 4, 7, 3, 4, 7, 5, 7, 9, 5, 7, 9. They are same. So here E transpose and matrix A are same. If transpose of any matrix is equal to matrix itself, then such matrix is said to be symmetric matrix. Such matrix is symmetric matrix. So A is a symmetric matrix. So definition is, if E is any square matrix and for any square matrix, for any square matrix A, for any square matrix A, if transpose of A is equal to A, transpose of given matrix is matrix itself, then matrix A is said to be symmetric matrix. And this is example. to understand this dimension. The A and A transpose are same, so this is symmetric matrix. Now, skew symmetric matrix. Skew symmetric matrix. Now, to understand this word, I take example. Suppose matrix A is, it's a special type of matrix. Suppose I take here 0, 2, minus 3, minus 2, 0, 5, here 3, 0, minus 5. This is matrix A. I take here minus 5, here 0. It's a special type of matrix. Keeping something in my mind, I have taken these entries. Say, look here. All diagonal elements are 0. All diagonal elements are 0. And observe remaining elements. Say, look here. These are opposite numbers. Similarly here. Reflection of these numbers, reflection of each one is its opposite number. Say here, these are opposite numbers. So if you find arrangement of numbers like this, then such matrix is said to be skew symmetric matrix. Say here, what will happen? If I take its transpose, if I take transpose of this matrix, then see, first row, I take first column. First row is first column. Second row is second column. Third row is third column. So this is transpose of this given matrix. Now, observe these two matrices. You can see that in this matrix and in this new matrix, sign of numbers are opposite. See, this is plus 2, here is minus 2. This is minus 2, here is plus 2. 3, minus 3. So all entries are having opposite sign. So to convert into the same matrix, to convert into the numbers which are in A, what I do, I take minus common. Taking minus common, take minus common from all these entries. So here 0, 2, minus 3, minus 2, 0, 5, 3, minus 5, 0. So taking minus common, that means what I have done? All entries I have multiplied by minus 1 and outside making into minus 1. So value cannot be changed. Value of this matrices remain unchanged. So in short, we can take something common from all entries. From all entries, minus is common, so take minus. If from all entries you find a 3 common, you can take 3 outside. Whenever we perform multiplication of matrix by a scalar, if 5 is multiplied to any matrix, then what we do? We multiply 5 with every entry in matrix. Now to reverse procedure, you multiply 5 each side with every entry, take that 5 common. So it is like 5 is become common. So 5 again it will come outside. So multiply inside. If you multiply inside, multiply every entry. If you find something common in every entry, take outside. When is common. So similarly here minus 1 is common. And now observe with this matrix. So you can see that these are same. It is A. So A transpose is equal to minus A. In this case, A transpose is equal to A. Here A transpose is minus A. So whenever A transpose is minus A, then matrix A is said to be skew symmetric matrix. Therefore, matrix A is skew symmetric matrix. For any square matrix A, if A transpose is minus A is skew symmetric matrix. For any matrix A, if A transpose is A, then A is symmetric matrix. So here, for any square matrix A, if A transpose is minus A, then matrix A is said to be skew symmetric matrix. Skew symmetric matrix. And here this is example. Now properties. For any two matrices A and B of suitable orders, so properties are, if we take sum of two matrices A plus B and two matrices, whatever you get the result, a new matrix, take transpose of a matrix obtained by addition of two matrices. On other side, put individual matrices. These are individual matrices. Sorry, these are individual transpose. And individual transpose of given matrices. So these values will be same. Transpose of addition of two matrices is equal to addition of their individual transposes. Transpose of sum is equal to sum of their individual transposes. Then, if we multiply any matrix by a scalar k, then we get a new matrix k times A. Then take transpose of this new matrix after multiplication by scalar. On other side, first of all, you take transpose of that matrix. After taking transpose, whatever is obtained, that matrix you multiply by scalar. These both matrices are same. So remember, this is a symbol, it's not a power. Transpose of a matrix obtained by scalar multiplication is equal to multiplying scalar by multiplying transpose by scalar. Then if we take product of two matrices, and product gives a new matrix, or given matrices A and B of suitable order. Say A and B are matrices such that product is defined. So suitable order. So after getting product, take its transpose. On other side, take their individual transposes. Transpose of AB, and here A transpose into B transpose, this is not equal. As transpose of sum is equal to sum of their individual transpose. Similarly, transpose of product is not equal to product of their individual transposes in the same order. But what is correct? But correct statement is transpose of AB is equal to B transpose into A transpose. Here you have to change the order. This is correct statement. Transpose of A into B is equal to transpose of B into transpose of A. Then if you take transpose, take once again transpose, so we get same matrix. Then now fifth property, any square matrix let me take A can be expressed as the sum of two matrices such that, let me take sum of two matrices x and y such that x and y such that x is a symmetric matrix and y is a skew symmetric matrix. X is a symmetric matrix. X is a symmetric matrix and y is a skew symmetric matrix. Any matrix A can be expressed as sum of two matrices. If you are given any matrix A, this is A, it can be expressed as sum of two matrices x and y such that this x is a symmetric matrix and this y is skew symmetric matrix. Any matrix A can be expressed as sum of two matrices x and y such that this x is a symmetric matrix, y is a skew symmetric matrix. And this x and y can be found by where x can be found by 1 by 2 times A plus A transpose and y can be computed by 1 by 2 times A minus A transpose. See this matrix, it will be symmetric matrix. This matrix will be skew symmetric matrix. Remember, for any matrix A, for any square matrix, if you add A transpose in A, then this matrix is always symmetric matrix. And if you subtract its transpose from A, then this is always skew symmetric matrix. Remember these two statements. Any square matrix A is given In that matrix, if you add its transpose, see this is any square matrix, whether it is symmetric or not symmetric. But if you add its transpose, then new matrix is always symmetric. And to this symmetric matrix, if you multiply 1 by 2, even though it remains symmetric, this is always a skew symmetric. In any matrix, square matrix, if you subtract its transpose, then new matrix is always a skew symmetric. And to skew symmetric matrix, if you multiply by 1 by 2, then it remains a skew symmetric. This is symmetric, therefore this is symmetric. This is skew symmetric, then therefore this is skew symmetric. And if you take addition of these two, if you add this matrix as well and this matrix, so addition gives 2 times A. 2 times A is equal to this expression plus this expression. So A is equal to 1 by 2 times this expression plus 1 by 2 times this expression. That's why here 1 by 2 is taken. If you add these two matrices, x plus y, see, if you take sum of x and y, so doing addition, 1 by 2 times A plus 1 by 2 times A, it will be equal to A, because this part will be cancelled. So any matrix can be expressed as sum of two matrices such that one matrix is a symmetric and another matrix is skew symmetric, and these matrices x and y can be derived, can be computed by this formula. If A and B are matrices, then verify that transpose of A plus B is equal to transpose of A plus transpose of B. So to verify this, first of all, we find A plus B. So here A plus B equal to matrix A is minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1, plus B is minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. A plus B. It is equal to minus 1 plus minus 4 is minus 5. 2 plus 1 is 3. 3 plus minus 5 is minus 2. 5 plus 1 is 6. 7 plus 2 is 9. 9 plus 0 is 9. Minus 2 plus 1 is minus 1. 1 plus 3 is 4. 1 plus 1 is 2. So this is A plus B. It is A plus B. Now I take its transpose. Therefore, transpose of A plus B, transpose of this matrix. So to obtain its transpose, first row I convert into first column. Second row is second column. Third row is third column. So this is, we say result 1. It is value of left hand side. Now we want A transpose plus B transpose. A transpose. A transpose is, I take A transpose plus B transpose. Now see, A transpose. So I take the value of A transpose. This is A. So its transpose is, first row is first column. Second row is second column. third row is third column. It is transpose of A. Then plus, then I give here plus. Then I give here transpose of B. So look B. First row is first column. Second row is second column. Third row is third column. So this is sum of these matrices. Minus 1 plus minus 4 is minus 5. 5 plus 1 is 6. Minus 2 plus 1 is minus 1. 2 plus 1 is 3. 7 plus 2 is 9. 1 plus 3 is 4. 3 plus minus 5 is minus 2. 9 plus 0 is 9. 1 plus 1 is 2. So this is value of right hand side. So this is A transpose plus B transpose. Now see, result 1 and result 2. You can see that. See, these two matrices are same. So from 1 and 2, these are equal. So from 1 and 2, it is clear that A plus B, its transpose equal to A transpose plus B transpose. So here we have proved a property. So first of all, we have given sum of given matrices. After getting sum, it's a new matrix. Then we have taken its a transpose. So transpose of this matrix. On the other hand, these are individual transposes. Transpose of A plus transpose of B. So sum of individual transpose is here. So sum of individual transpose is equal to transpose of sum. Transpose of sum is equal to sum of individual transposes. Now here, see, A dash is given. So from A dash, first of all, we calculate A because A is not given. So here, A is transpose of transpose. Matrix A is transpose of transpose. So that is, now see here, transpose of A is given. Now what we are doing? We are taking transpose of this matrix. So transpose of this matrix. So first row is first column. Second row is second column. Third row is third column. So this is A. B is already given. Now, to verify this, first of all, we find A minus B. Difference of these two matrices. A minus B. A is, here we have found 3 minus 1 0, 4 2 1 minus. B is minus 1 2 1 1 2 3. So it is equal to, now difference of this matrix is 3 minus minus 1. So it is 3 plus 1 is 4. Minus 1 minus 2 is minus 3. 0 minus 1. 4 minus 1 is 3. 2 minus 2 is 0. 1 minus 3 is minus 2. So we have found A minus B. Now it's transpose. So its transpose is transpose of this matrix. So we convert these rows into column. 4 minus 3 minus 1. First row is first column. Second row is second column. So this is value of left hand side. Now we find A dash minus B dash and transpose of A minus transpose of B. Transpose of A is given. It is 3, 4, minus 1, 2, 0, 1, minus. Now here we get transpose of B. Transpose of B, that is, see, this is B. From B, taking its transpose, first row, take first column. First row is converted into first column. Second row, now it becomes second column. So this is transpose of B. Taking difference, 3 minus minus 1 is 4. 4 minus 1 is 3. Minus 1 minus 2 is minus 3. 2 minus 2 is 0. 0 minus 1 is minus 1. 1 minus 3 is minus 2. So it is 2. Now look these two matrices. See, they are same. So from 1 and 2, transpose of A minus B is equal to A transpose minus B transpose. So from 1 and 2, transpose of A minus B is transpose of A minus transpose of B is true. For the matrices A and B, verify that transpose of A into B is equal to B transpose of B into transpose of A. It's a property. And this property we verify for these two matrices. So say, first of all, we find product. Here product of A and B. A is 1 minus 4, 3. B is minus 1, 2. Now see, order of A, it is 3 by 1. 3 by 1. Order of B is 1 by 3. 1 by 3. This is order of A, this is order of B. So multiplying A and B, you will have a new matrix whose order will be 3 by 3. So new matrix by product, it will be 3 by 3, and the procedure is always we draw circles over rows in first matrix and circles over columns in second matrix. Then we take first row in first matrix, multiply with first column. 1 into minus 1 is minus 1. One element, one element. If there are here two elements, there will be here two elements. Then we take sum of products. If there are three elements, then here there will be three elements. So we take sum of three products, but only one. So this is itself product. Then 1 into 2, that is 2. 1 into 1, that is 1. Then close this side. Now term of second row. Minus 4 into minus 1 is 4. This will be minus 8. This will be minus 4. Term of 3. 3 into minus 1 minus 3. 6, 3. So it is E into E. Now we take its transpose. Now transpose is, therefore, transpose of this matrix is, taking its transpose, first row is first column, second row is second column, third row is third column. So converting rows into column, this is transpose of this matrix. So it is value of left hand side, we say this is 1. Now on other hand, we find b dash into a dash and b dash into a dash. Transpose of b, transpose of b. This is a row matrix. Its transpose will be a column matrix. Row is converted into column, then into a dash. This is A. So its transpose will be converting rows into columns. See, 3 rows. We convert into 3 columns. So first row is first column. Second row is second column. Third row is third column. Taking transpose of a row matrix, it is converted into column matrix. And taking transpose of column matrix, it will be converted into row matrix. And now multiplying by this method. Here, taking circles over rows and here in columns. So here minus 1 into 1 is minus 1. Minus 1 into minus 4 is 4. Minus 1 into 3 is minus 3. 2 into 1 is 2. 2 into minus 4 is minus 8. 6. 1 into 1 is 1. Minus 4. 3. And now compare with this value. See, they are equal. So this is 2. So from 1 and 2, transpose of AB is equal to B transpose into A transpose. Then next question. This is A. Verify that A dash into A is I. See here. First of all, we find transpose. Transpose of A. Transpose of A. First row is first column. Second row is second column. First row is here, first column. Second row is second column. So it is transpose of A. Now, we compute A dash into A. A dash into A. On left, matrix A dash. So I take here A dash. A dash is sin alpha minus cos alpha. Cos alpha, sin alpha. Into A. A is sin alpha cos alpha minus cos alpha sin alpha. So this is A. This is A. Now multiplying this. First row we multiply with these columns. Sin alpha into sin alpha is sin square alpha plus minus cos alpha into minus cos alpha is cos square alpha. Then we multiply this with second column. Sin alpha into cos alpha plus minus cos alpha into sin alpha minus cos alpha into sin alpha. Now second line. Term of second line. Cos alpha into sin alpha plus product of these two numbers, that is minus sin alpha into cos alpha. Then multiply this with second one. Cos alpha into cos alpha is cos square alpha plus sin square alpha. So it is equal to This is 1. This will be 0. This cancel. This will be cancelled. So 0. This is 1. And see, this is identity matrix. Identity matrix of order 2. So it is I. Therefore, A dash into A is identity matrix. Show that this matrix is a symmetric matrix. To show any matrix as a symmetric matrix, by definition, we have to prove that transpose of A is equal to A itself. Then it is said to be symmetric matrix. So here we find transpose. E is given, so its transpose is equal to 1. First row is first column. Second row is second column. Third row is third column. And now compare. Converting all 3 rows into corresponding column, even though it remains same. Say here, these matrices are same. So A transpose is equal to A. A transpose is equal to A. And if transpose of any matrix is matrix itself, then A is a symmetric matrix. So it's a symmetric matrix. Now to show that this is a skew symmetric matrix, we have to prove that its transpose is equal to minus A. So again, here we find its transpose. Transpose of A. See, first row is first column. Second row is second column. Third row is third column. 3 rows converted into corresponding columns. So it is its transpose. Now look these 2 matrices. In every entry, sign is opposite. So what we do? We take a minus common from these all entries. So taking minus common, 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. And taking minus common, you can see that this is A. So minus of A. Therefore, transpose of A is equal to additive inverse of A. So A is skew symmetric matrix. It is a skew symmetric matrix. Whenever you are asked to prove given matrix, a skew symmetric matrix, always show transpose, its transpose is equal to minus of that matrix. And whenever you are asked to prove given matrix as a symmetric matrix, show that its transpose is equal to itself. Now here, express this matrix as the sum of a symmetric and skew symmetric matrix. Let me say this matrix as A. A is 3, 5, 1, minus 1. So when discussing property, we discussed that any matrix can be expressed as sum of 2 matrices x and y such that x is a symmetric matrix and y is a skew symmetric matrix. The theory part, so we discussed this. Any matrix A can be expressed as sum of 2 matrices such that X is symmetric matrix, Y is skew symmetric matrix. where x can be computed by 1 by 2 times a plus a dash, and y can be computed by 1 by 2 times a minus a dash. So this property we discussed. So using this property here, so A is given. Now we want to find such two matrices. So formula for x, 1 by 2 times A plus A transpose. Now look, A transpose is required in computing x and y. So first of all, from A we calculate A transpose. A transpose is equal to, first row is first column, second row is second column, A transpose. Now we calculate x. X is 1 by 2 times A plus A transpose. So x is equal to 1 by 2 times A is 3, 5, 1 minus 1 plus A transpose is 3, 1, 5 minus 1. A plus A transpose. So it is 1 by 2 times 3 plus 3, 6, 5 plus 1, 6, 1 plus 5, 6, minus 1 plus minus 1, minus 2. So this is 3, 3, 3, minus 1. X equal to 1 by 2 times A plus A transpose, putting value of A and A transpose, computing this is X. Here X is obtained. X is obtained. Now we show that X is symmetric matrix. So to show that X is symmetric matrix, we have to show that its transpose is equal to itself. So for which we find x dash. So x dash is equal to, x dash is, see, first row is first column, second row is second column, first row is first column, second row is second column, and look, this is x. X dash is equal to x. It is equal to x. So x dash is equal to x. Therefore, x is a symmetric matrix. So x by this formula is a symmetric matrix. This step is required. You have to prove that x is a symmetric matrix after getting x by this formula. Now we calculate y. Y is equal to, this is for y, 1 by 2 times a minus a dash, 1 by 2 times a minus a dash. That is 1 by 2 times a is 3, 5, 1 minus 1, minus a dash is 3, 1, 5 minus 1. So it is 1 by 2 times 3 minus 3 is 0, 5 minus 1 is 4, 1 minus 5 is minus 4, minus 1 minus minus 1, that is 0. So it is 0, 2, minus 2, 0. So this is y. Here, this is y. Now we show that y is skew symmetric matrix. For which, now to show that y is skew symmetric matrix, so we are going to show that y dash is equal to minus y. So y dash is equal to y dash. Now it's transpose. See, first row is first column. Second row is now second column. This is y dash. Now taking minus common, this will be 0, 2, minus 2, 0. So say this is y. So it is equal to minus y. That means y dash is equal to minus y is true. Therefore, y is a skew symmetric matrix. So y is a skew symmetric matrix. So y is also formed. Now we check sum of x and y. Sum of x and y should be a. Now x plus y. X is a symmetric matrix. This is x. X is 3, 3, 3 minus 1 plus y. It is a skew symmetric matrix. This is y. 0, 2, minus 2, 0. 0, 2, minus 2, 0. So adding this matrices, 3 plus 0 is 3, 3 plus 2 is 5, 3 plus minus 2 is 1, minus 1 plus 0 is minus 1, and say this is given matrix A. See, A is obtained. So it is equal to A. Thus, we have expressed A as sum of these two matrices, in which first matrix is symmetric, second matrix is skew symmetric. Thus, A is expressed as sum of a symmetric and a skew symmetric matrix. Express this matrix as the sum of a symmetric and a skew symmetric matrix. Exactly similar manner. Just we performing last question. Again, we take this matrix as A. Let A be 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. This is A. So we find its transpose, which will be required in computing x and y. So A dash is first row is first column, second row is second column, third row is third column. Now we take x equal to formula for x 1 by 2 into A plus A dash. So it is equal to 1 by 2 into. Now A is here 3, 3 minus 1. We can add directly now A plus A dash. See, A plus A dash. 3 plus 3, that is 6. 3 plus minus 2 is 1. Minus 1 plus minus 4 is minus 5. Minus 2 plus 3 is 1. Minus 2 plus minus 2 is minus 4. 1 plus minus 5 is minus 4. Minus 4 plus minus 1 is minus 5. Minus 5 plus 1 is minus 4. 2 plus 2 is 4. This is x. Now multiplying 1 by 2 inside. So this will be 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, minus 5 by 2, minus 2, 2. So this is x. Now we show that x is a symmetric matrix. So for which we find it's a transpose. To show that x is a symmetric matrix, we are going to show that x dash is equal to x. So x dash is, so taking its transpose, first row is now first column. See, first row is first column. Second row converting in second column. Third row converting in third column. Converting all rows into column. Now look, compare this two. So you can see that they are ditto, same. So x dash is equal to x. So that means x dash is equal to x. Therefore, x is a symmetric matrix. X is a symmetric matrix. This is a symmetric matrix. By this formula, if you compute x for any given square matrix A, x will be always symmetric matrix. Now we compute y, and y is 1 by 2 into A minus A transpose. Now difference of these two matrices, A minus A transpose. So taking difference here, see 3 minus 3 is 0. 3 minus minus 2 is 5. Minus 1 minus 4 is 3. Minus 2 minus 3 is minus 5. Minus 2 minus minus 2, that is 0. 1 minus minus 5 is 6. Minus 4 minus minus 1 is minus 3. Minus 5 minus 1 is minus 6. And 2 minus 2 is 0. That is, multiply 1 by 2, 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. It is y. Now we show that y is a skew symmetric matrix, for which we show that y dash is equal to minus y. So now y dash, so it's a transpose. So its transpose is first row is first column, second row is second column. See, first row is first column, second row is second column. Third row is third column. Now taking minus common from this, taking minus common, 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. And now you can see that this is minus of, say, this is y. It is same as y, minus y. So y dash is equal to minus 1. So y is a skew symmetric matrix. So x is a symmetric, y is a skew symmetric. Now we add x and y. Now x plus y. Sum of this symmetric and skew symmetric matrix, we are going to show that it is given matrix. So putting value of x is, say look, there is x, 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, minus 5 by 2, minus 2, 2, plus y is, this is y, 0, 5 minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. This is symmetric, this is skew symmetric, and their sum is 3 plus 0 is 3. 1 by 2 plus 5 by 2 is 6 by 2. 6 by 2 is 3. Minus 5 by 2 plus 3 by 2 is minus 2 by 2. That is minus 1. 1 by 2 minus 5 by 2 is minus 4 by 2. That is minus 2. Minus 2 plus 0 is minus 2. Minus 2 plus 3 is 1. Minus 5 by 2 minus 3 by 2. That is minus 4. Sum of these two numbers is minus 5, 2. And look, this matrix. It is matrix, given matrix A. This is given matrix A. So it is equal to A. Given matrix. Thus, A can be expressed